Hello friends, welcome to my channel Study Goals. If you haven't subscribed my channel, then subscribe my channel and press the bell icon for getting more video updates. If you have some doubt, ask in comment section and I will try to solve your queries. And you also give the feedback of my video contents that what should I improve. The video made up of quality content, so please friends watch the video till the end. You get something new from it and your questions would be solved. In last session, we done completely the cold junction compensation of thermocouple. So friends, if you want to go through it, please click on the I button which shows on the topmost corner of the video. And also you want to check out in comment section where I put the link of cold junction compensation techniques. So let's start with the fresh topic, that is thermistor, in which we have to understand about what is a thermistor, their definition, how is it works and their operation, working principle, how the construction of thermistor obtained, their symbolic representation, characteristic, and finally their application we will see in the video. So friends, watch out the video till the end. What is thermistor? A thermistor or a thermal resistor is defined as a type of resistor whose electrical resistance varies with change in temperature. Although all the resistor resistance will fluctuate slightly with temperature, so we can say that thermistor is a particularly sensitive to temperature changes. Basically, thermistor act as a passive component in a circuit. They are accurate, cheap, and a robust way to measure a temperature. While they do not work well in extremely hot or a cold temperature because they are the sensor of choice for a many different applications. Also, they are idle when a precise temperature reading is required. As you can see the symbolic representation of thermistor in a screen, which is mostly represented internationally by this symbol. Construction of thermistor: when two or more semiconductor powders made of metallic oxides are mixed with a binder or a cover type to form a slurry or a semi-liquid mixture. Small drops of slurry are formed over the lead wires. For drying purpose, we have to put it into a sintering furnace, which means here a process obtains in which we have to made thermistor compact in size and made such as having good mechanical strength. During this process, that slurry will shrink into the lead wires to make an electrical connection. So this process, metallic oxide is sealed by putting a glass coating on it. This glass coating gives a waterproof property to thermistor, helping to improve their stability. There are different shapes and sizes of thermistor available in market. Smaller thermistor are in the form of beads of thermistor diameter from 0.15 mm to 1.5 mm. Thermistor may also be in the form of disc and washers made by pressing the thermistor material under high pressure into a flat cylindrical shape with diameter from 3 mm to 25 mm. Now, the working of thermistor. The question arises in your mind that how does the thermistor work? So let's discuss about its working. As you can see the graph, which is non-linear, that shows the working principle of a thermistor is that its resistance is dependent on its temperature. We can measure the resistance of a thermistor using an ohm meter or electrical breath circuit. If we know the exact relationship between how changes in the temperature will affect the resistance of thermistor, then by measuring the thermistor resistance, we can derive its temperature. How much a resistance changes depends on the type of material used in thermistor. That's why the relationship between the thermistor temperature and the resistance is non-linear. A typical thermistor graph is shown in below your screen. In another way, we can understand that a change in temperature is inversely proportional to electrical resistance. That means whenever there is an increase in temperature, then there is a decrease in resistance, similarly and vice versa. Now, the types of thermistor. Let's talk about it. Basically, there are two types of thermistor through which we can measure the temperature. First one is the NTC, that is negative temperature coefficient. The NTC type of thermistor is made up of semiconductor. In NTC, when the temperature increases, then there is a decrease in resistance. That's why it is known as NTC type thermistor. It shows nonlinear graph, most commonly used in market, and it is so popular. Here it is used in air conditioning application. Second one is a PTC, that is positive temperature coefficient. The PTC type of thermistor is also made up of semiconductor. In PTC, when the temperature decreases, then there is an increase in resistance coefficient. That's why it is known as a PTC type thermistor. It is not much popular in as compared to NTC. For example, it is used in current limiting application such as fuse. Next one is a thermistor characteristic. The relationship, as you can see, which governs the characteristic of thermistor. The equation is given below, that is R1 is equals to R2 e raised to beta in bracket 1 by T1 minus 1 by T2 bracket close, where R1 is the resistance of thermistor at absolute temperature T1, that is in Kelvin. R2 is the temperature resistance of thermistor at temperature T2, which is in Kelvin. Beta, that is constant depending upon the material of transducer. We can see in the equation above that the relationship between temperature and resistance is highly nonlinear. A standard NTC thermistor usually exhibits a negative thermal resistance temperature coefficient of about 0.05 per degree Celsius. Let's talk about the application of thermistor. It is used in digital thermometer or the thermostat. It is also used in automotive application to measure oil and coolant temperature in cars and trucks. Thermistor is used in household appliances like in microwaves, in fridge and in ovens. It is also used to protect the circuit, or it is also used in surge protection. It is used as rechargeable batteries to ensure the correct battery temperature, whether it is maintained or not. It is also used to measure the thermal conductivity of electrical materials. Finally, we completed the thermistor topic. I hope you learn and understand from this video. So thank you for your support. Take care and stay safe.